And I want to talk about geodata. What are we doing with this?
Well, this brings me to an next question for another panelist, namely Dr. Thomas Usländer from the Karlsruhe Fraunhofer IOSB. I know everybody's interested in geodata and networking, but Dr. Usländer, we would like to have a look at the way you're dealing with geodata. And you have said that data are the gold in the Internet of Things, and you're a specialist in the field of sensor technology and sensor data management. Now, how about technological development on the one hand and handling of data on the other hand, and the conclusions one can derive from that, especially looking towards a smart city idea? Well, thanks for the question. No matter which domain you want to make smart, whether it's the energy sector or a smart city or the production hall, we need data in order to feed them into the systems, and in order to collect the data and process the data efficiently, rather than having to do the same thing again, the same kind of data conversion again and again. Now, for that purpose, we need open geo and sensor data and management architecture. There are some initial approaches already available. There are standards of the Geospatial Consortium and by others, and that's something that has to be spread more widely, which has to become known amongst the stakeholders, going beyond the individual domain limits, because we cannot keep reinventing the wheel, otherwise the applications will not be profitable anymore. And although all the things, of course, have to be smart, we also have to have a proper business case. And of course, we've got to maintain the solutions, we've got to update them. And if we cannot focus and agree on standards in this regard, and if we don't use and apply the standards, then we will end up in a situation where we don't have a digital ecosystem, but that rather these markets are dominated by big IT players only. And I think not everybody would love that idea. I think we need more interoperability. Now, you mentioned different types of data formats, and Fraunhofer IOSB wants to create a new uniform standard or contribute to it, and you have developed an open source software for that purpose, for the sake of evaluating and further processing of data. Now, what's the current status of that software? How far have you gone with that project? Well, this standard is called SensorThings API. It's a modern interface in order to access sensor data and execute actions in the field of sensor data collection. This SensorThings API standard comes from the OSI, and we're also heading the working party which is driving that standard forward together with a colleague from Canada. We've got an open source implementation which is called Fraunhofer Open Source API Server. Frost also means that we keep your data fresh and cool, by the way. And this open source implementation is actually the only reference implementation at this point. There are other commercially available implementations and also a lot of applications in different cities all over the world, all the way to Taiwan, for example, where the new application has been set up in the field of air quality. Well, talking about data, when we talk about gathering and collecting data from the air, from the ground, whether we're talking about autonomous driving or BIM or smart city as such, well, the whole point always is that citizens are somewhat affected by it, but they can also play a shaping role. And what's the role the citizen plays in your approach? Well, from a technological point of view, it's also a sensor. Every human is a sensor, making observations and feeding the data into the overall system. But observations by a human have got a different type. They are somewhat softer. You cannot immediately derive a time series from such an observation. It's rather text-based statements or observations coming as images or videos. So other videos come into the play as well. And especially when you talk about the smart city applications, the magic thing is to bring all of these things together and combine them with physically measured data. And here, once again, standards will help, because uncertainties you might have must be describable via a formal language to make sure that the data from different sources can all be processed together. One example, let's say you have got a measuring network for air quality. That's one thing where you can collect data on a regular basis. But then, on the other hand, you might also want to gather observations from citizens who say, well, there's a strange smell in the air here. And if you're able to input this into the system in an objective manner, then this helps very much. Well, final question for you, and of course politics is an important player as well, development in the society, and Stuttgart is such a hotspot for air quality, for example. Here we've got particle emissions causing a major problem to air quality here in Stuttgart, and here of course the quality of the data measured is also very relevant. Yes, I mean, I think experts all know that the problem of particle emissions cannot be pinpointed to a single spot or a single location only. You rather need to use technologies, gathering measurements from various locations. You need to take the potential of spread of particle emissions into account. And then, of course, you need to first of all validate the data in order to reach an improvement rather than just focusing on one single spot. Of course, that requires a certain willingness to move forward, and it's not really an easy undertaking, but I think the present conclusions that have been drawn so far are not really reliable.